Hello everyone, I am Ha-Ying Chu from Institute of Data Science and Knowledge Engineering, School of Computer Science in Beijing Institute of Technology. In this chapter, we introduced some useful platforms, Spark MLlib and TensorFlow. And in this session, we will talk about a typical big data analysis application, recommendation system. A recommendation system is a subclass of information filtering system that seeks to predict the rating or the preference a user might give to an item. In simple words, it is an algorithm that suggests relevant items to users. Recommendation systems is widely used in many fields like Netflix, Amazon, JD, Taobao, QQ Music, etc. Recommendation algorithms can be roughly divided into three categories: collaborative filtering, content-based, and knowledge-based. And the big difference between collaborative filtering algorithm and content-based algorithm is that content-based algorithm relies on the item features themselves, but the collaborative filtering relies on how other users respond to the same item. Collaborative filtering can be further divided into neighborhood-based and model-based. Neighborhood-based algorithm includes user-based and item-based algorithms, and we will discuss in this session. Model-based algorithms include latent factor model, graph model, and others. In latent factor model, I will use metric factorization as an example to explain. The content-based recommendation algorithms recommends items based on item features, which include the structured features and unstructured features. And the third category is knowledge-based algorithms. Let's look at the diagram on the left. It is the collaborative filtering, exampled by user-based filtering algorithms. It shows that the similar users will have the similar preference for articles. And the similar users are defined based on the common articles, the green and the red articles they read. Since they are similar users, the article read by her, the blue article, can be recommended to him. On the right, it is a content-based filtering recommendation. The red article and the green article are defined similar articles based on the article's features. And when the red article is read by the user, the green article will be recommended to the same user. This picture shows the user-based filtering and item-based filtering. In user-based filtering, we find the similar users based on the common items they chose before. Here, Tim chose ice cream with egg roll, chocolate, ice cream cone, and donut. And John chose chocolate, ice cream, corn. Tim and John have certain items in common. Then we define them similar users. For the items Tim has chosen and John not, we can recommend to John. Here are the ice cream with egg roll and donut. In item-based filtering, we defined the ice cream with egg roll and ice cream cone as similar items based on the user chosen behavior. And John has chosen the ice cream cone, so we recommend the ice cream with egg roll to him. We will explain the user-based filtering and item-based filtering in detail. In this session, we will explain three main recommendation system algorithms: user-based filtering, item-based filtering, and content-based filtering. First, let's look at user-based filtering recommendation system algorithms. The steps for user-based filtering are shown in the diagram. First, we collect the user purchase records. Second, we build item to user table based on the user purchased records. The user-to-user matrix is built based on the item to user table. This is the third step. And the fourth step is the user-to-user similarity matrix is built based on the user-to-user matrix. And the fifth step is calculate the user's interest in different items. And the sixth get recommendations result based on the user's interest in different items. User-based collaborative filtering is an algorithmic framework where the similar users are identified based on the similarity with the active user. And then scoring of the items is done based on the neighbor's rating, followed by a recommendation of an item based on item's score by the recommendation system. Multiple users choose many of the same items. We can call these users similar users. In the user-based collaborative filtering algorithm, we believe that a user will like items that his or her similar user like with higher probability. So, how to calculate the similarity of the users? Usually, use Jaccard similarity, cosine similarity, and Euclidean distance and Pearson distance to calculate the similarity between two users. Let NU be the set of the items that user U likes, and NV be the set of the items that user V likes. Jaccard similarity, cosine similarity calculation methods are shown here. Let us make an example to get a recommendation result using user-based collaborative filtering. Here, the big A, B, C, D letters are users, and the small A, B, C, D, and E are items. Based on the user purchased records, we built the item user table, which shows for each item all the users who have purchased this item. For example, item A is purchased by user A and B. Item B is purchased by user A and C, etc. Then, user-user matrix is built based on the item to user table, in the way that each element value is the numbers of common items purchased by the row user and the column user. For example, the element of the first row and the second column is calculated by the common items number of user A and B. They have just one common item, which is the item A, so the value is 1. The other matrix element value is calculated in the same way. Based on the user-user matrix we just calculated, use cosine similarity, we can calculate the user-user similarity matrix. Each element in this matrix is the similarities of the user in corresponding row and the user in corresponding column. Here, NU is the set of the items that user U likes, and NV is the set of the items that user V likes. After we have the user-user similarity matrix, For each candidate item I, the degree that the user U is interested in it is PUI, can be computed using the above formula. Suppose we want to recommend items to user A. Select K equals to 3 similar users, and the similar users are B, C, and D. Based on the user-to-user similarity matrix, then the items that B, C, and D chose and A has not chosen are C and E. Then calculate user A's interest in item C, PAC, and item E, PAE, respectively. They both are 0.7416, which means user A likes C and E atom equally. Now let's look at the item-based collaborative filtering. Calculate the similarity between items and recommend items with high similarity to the items chosen by users. In the item-based collaborative filtering algorithm, we believe that the similarity between item A and item B is because users who like item A also like item B. The calculation is also based on the user purchase record. Item-to-item matrix is computed based on that. In the item-to-item matrix, each element is the number of the user who chose the item in the corresponding row and the item in the corresponding column. For example, on the right, in the item-to-item matrix, the value of the element in the first row, second column, the number of the users who choose both item A and item B is 1, just user A. The other elements can be calculated in the same way. Now let's calculate the similarity of items. Let Ni be the set of users who like item I, and Nj be the set of the users who likes item J, and the intersection of Ni and Nj be the number of the users who like both item I and item J. Cosine similarity of item I and item J, Wij, can be calculated as the formula. The number of the interaction of Ni and Nj divided by the number of Ni and Nj. Item-item similarity matrix can be calculated using cosine similarity based on item-to-item matrix, as shown on the right matrix. Now let's compute the user's interest in different items. For each candidate item J, the degree user U interested in item J, PUJ, can be calculated as the formula shows, where NU represents the collection of items favored by user U. SJK is the collection of K items most like item J. Wij is the similarity between item I and item J, and RUI represents the user U's interest in item I. Now we can get recommendation result. Suppose we want to recommend items to user B. Select K equals to 3 similar items, so the items user B has not chosen before are B, D, and E item. Then calculate P, B, D, PBB, and PBE respectively. The result is 1, 0.5, and 0.5. Then we think user B likes D most, and user B likes B and E equally. For user-based filtering, how to calculate the degree of users' interest in candidate items based on users? We need to establish a connection between the user and the candidate item. And the connection is the user similarity. For example, on the left, we calculate the user A's interest degree in item C. In PAC, the items have been purchased by users are B and D, so add the similarity of WAB and WAD. And for item-based filtering, how to calculate the degree of users' interest in candidate item based on items? We still need to establish a connection between the user and the candidate items, and the connection is the item similarity. For example, on the left, we calculate user B's interest degree in item D in PBD. The items have been purchased are item A and item C, so add the similarity of WDA and WDC. Now let's look at content-based filtering. Content-based filtering recommendations is the first recommendation algorithms that recommends items similar to a user's past favorite items. The key here is the measure of item similarity, which is the core of the algorithm application process. Three main steps of content-based filtering is the first one, item representation, which is extracting some features for each item to represent them. And the second step is profile learning, which means using the feature data of a user's past favorite or not favorite items to learn the user's preference features. That is user's profile. The third step, recommendation generation. By comparing the user's profile obtained in the previous steps with the features of the candidate items, a set of items with the highest relevance is recommended to this user. In this session, we learned three main recommendation system algorithms: user-based filtering, item-based filtering, and content-based filtering. Thank you for your attention. If you have any question, feel free to contact me.